In a recent episode, we talked about your background as a Kafka committer, PMC member, how Kafka works, and the massive data scale you were dealing with at Hortonworks and Uber. And that all led to a discussion into kind of push versus pull architecture decision for metadata ingestion, and why, with all your experience, you chose to not use Kafka for open metadata.
Yeah, that sounds good. I'm going to kind of continue with the last episode where we kind of showed the diagrams and everything, which will help us articulate better. So with that, I'm going to share my screen.
Okay.
So just to kind of land it here, right? So what is Kafka used? Kafka used for in many organizations a way to distribute the load of your logs, your analytics, your events. Could be any events, right? The context of why Kafka is important, why Kafka can scale is you have the same data. Let's say you have application logs that are pushing from your online e-commerce platform into
Mhm.
Kafka. Traditionally, before Kafka, people probably used to ship it to S. And again, there is a latencies and S3 rating and everything else. The idea here is if you're shipping for one use case, that's good. Any mechanism is good enough. But if you're shipping for many use cases, maybe there's a platform team who wants to understand how many clicks are happening on a particular product. That's one use case. Another team, probably an ML engineering team, wants to understand what's the user behavior coming into e-commerce platform, how
Yeah.
they are leading to one page to another page. Another team wants to develop, hey, what is the related items where the users are clicking? The related items could be, I probably searching for camera, I land on camera, maybe I go to a camera strap or something like that.
Mm.
So all of these are different use cases, but they probably land on the same data. So how do you enable one producer pushing the data and many consumers reading the data? So that's his ideal use case for Kafka. Latencies are important. Kafka enables you to kind of push millions or if not trillions of events and scale out independently on the consumer side to many of these use cases. So
Yeah.
you're not penalized to read the same data. And one consumer reading at their own pace doesn't affect another consumer either. So my use case probably I want to look at every hour, another use case probably every second, every millisecond. So
Yeah.
that's where the ideal scenario comes in for Kafka. Now, taking into account of what is a metadata looks like. So you have snowflakes, you have Tableau, you have dashboards and everything else.
Right.
In any of these data sources, let's take an example of Snowflake, Databricks. You have data warehouses. So whenever you create a table, whenever you alter the table, how does that particular event translate into a metadata event that can be captured and pushed into open metadata? So
Mm.
for that to happen, Snowflake needs to notify an external system that Harsha came in and created a table. Sean came in and altered a table.
Mhm.
So all of these things as a notifications or events, Snowflake has to provide an interface to listen to. It needs to enable a push mechanism so that a Kafka can capture that as an event. So,
Right.
so far in the industry, that hasn't happened. Outside of one or two, like Hive and Glue does that. Again, Glue does that through its own event hub in AWS, not through Kafka.
Mm.
So in that world, how do you actually enable Kafka-like system? So that's what we are trying to showcase here in the first image.
Mm.
So there should be a Kafka producer that is polling Snowflake for what happened in last 24 hours and take that events and push to Kafka. So your Kafka producer is running, polling constantly after Snowflake, push into Kafka. And other side, there's a Kafka consumer has to be that can pull
Yeah.
Kafka events that are there and push to metadata store. So this is a complex
Yeah.
architecture that you end up building. And the question always has to be from an architecture point of view, you want to minimize the components that you want.